everybody, and welcome back. This is the second video in our polar unit, and we're going to be converting between polar and rectangular coordinates. So we're going to be going between those xy's that we're very comfortable with and we plot points to the new form, which is our r comma thetas. And we're going to start by discovering the relationship that is between the polar coordinates and our rectangular coordinates. So here's our rectangular coordinate. And it is x comma y, and we know that x is the direction horizontally moved away from the origin, and y is the vertical direction from the origin. And then we have our r comma theta, where r is the radial measure, or the distance from the origin on a radius, and theta is the angle moving in the clockwise direction from the positive x-axis. So knowing all of that, and we got all of that from the first lesson, and then we're going to take a look to see how we can actually go between these two ideas. So I'm going to start by plotting a point out here. We're going to call it xy, and I'm going to connect it along a radius. So there's my r value. Now we know that moving along this direction we have our horizontal movement, and then vertically we have the y, so our y direction. And then we also have the theta measure here as the directional angle. So with all of that said, then we're going to be able to start to form some relationships. If I wanted to take a look at where r comes from and how we could calculate r if we knew our x and y values, if I knew the horizontal and the vertical distance. So if you think back to the vector chapter, your r actually comes from the Pythagorean theorem. Well, since I don't really care for r squared, and I'd rather just know what r is, then I'm going to take the square root of both sides, leaving us with the square root of x squared plus y squared. Now typically when you take a square root, you have both the positive and the negative values because the distance could be in either direction. If I were to look at the negative, I'd actually be looking at a completely different theta value, and we knew that from our previous lesson. So we're going to maintain that we're only looking at the positive value of r after taking the square root. And secondly, we do not want to take a square root of the values underneath. We want to take a square root of the sum of those values that are squared. So be careful, because if you do that out of the order of operations, you'll end up with an incorrect answer for your r value. Now, where does theta come from? If I don't include r whatsoever in my relationship of theta, then theta is actually based on a tangent relationship. So I should have tangent of theta equals y over x. Now we've thought of tangent as y over x before, so that's nothing new. And then I can solve for theta by using our inverse operation, so tan inverse of y over x. So keeping these in mind right here is actually the ideas that we'll have for converting from an xy. So if I'm given xy, here's how I will find r and theta. Notice that r equals only values containing x and y, and my theta is the tangent of that ratio. So let's go ahead and take a look at what if I was given r and theta, but I wanted to find the values of x and y in rectangular coordinates. To do that, I'm going to take a look at what is the relationship of r and theta when it comes to x or y. When I look here at x, I think, well, r and theta and x, what is the relationship between those three? And that's cosine. So I have the cosine of theta to equal x over r. If I multiply both sides by r, then I have x equals r times the cosine of theta. Again, if I was given r and theta, I would be able to calculate x. So what's the relationship between y, theta, and r? Well, that's a sine relationship. So the sine of theta equals y over r. Again, multiplying both sides by r, we have y equals r sine of theta. It shouldn't be surprising that x relates to cosine and y relates to sine. So the difference now is that we're not on a unit circle, and we're looking at what happens when there's a different radius involved. If I were just looking on a unit circle, then my r value is 1 and x equals the cosine of the angle. And if r equals 1 down here, then y equals the sine of the angle. And that's what we've been working with since chapter 1. All right, so now we're going to try to look and convert between these. So here point R is going to be given in rectangular coordinates, and we're going to convert it to polar coordinates. So it's 3 root 2 comma 3 root 2. Now you think on a unit circle, 3 root 2 is actually not going to show up on our unit circle, so there must be a different radius involved. So taking a look at that, we're going to say, I know my x and y. How do I find my r and theta? That's our goal. So if I want to find r, we had the formula from above or from previously that x squared plus y squared. Let's substitute the values in. R equals the square root of 3 radical 2 squared plus 3 radical 2 squared. When I go ahead and square those, make sure you're squaring everything correctly. If I square the quantity here, I'm going to square the outside and then remove the radical from the 2. So it'll be 9 times 2. So it's actually going to be 18. Same thing on this side, which means that r is equal to the square root of 36, or r equals 6. So if I'm going to consider this, my r value, my converted polar coordinates, is going to be r 6 comma something. Now I also want to think about where this is located on my coordinate plane. It's a positive positive, so it has to be located somewhere here in the first quadrant. The reason I bring that up is that when we find theta, we better find an angle that falls in the first quadrant. So let's go ahead and calculate. So I'm going to have tangent of theta will equal 3 root 2 over 3 root 2. That means that the tangent of theta equals 1. So we can think, where is the tangent equal to positive 1? What angle value? If you're unsure, remember we can always use our tan inverse of 1, and that should give us theta equal to 45 degrees. Now just because theta comes up as 45 degrees doesn't mean that it's the correct answer. Remember, tangent will also equal 1 over in the third quadrant because you'd have a negative root 3 over 2 over a negative root 3 over 2 would still simplify to a positive 1. So we have to eliminate that possibility because I know my rectangular coordinates fall in quadrant 1. So my answer is 6 comma 45 degrees. Putting the degree symbol there is extremely important, or otherwise I actually might consider this a rectangular coordinate at 6 comma 45. That's not what we're doing. We're doing 6 is the radius measure and 45 is the angle measure. Let's try another one. So for this one, I'm going to give it to you in polar coordinates. That means I'm going to give you 3 comma 150 degrees. You know it's polar because of the degree symbol. And we're going to convert this to rectangular coordinates. So this time I'm using x equals r times the cosine of theta, and x equals, or y, excuse me, equals r times the sine of theta. That's how we're going to convert this one. So since I know my r value equals 3, I just have to determine what the cosine of 150 degrees is. So this is going to be 3 times the cosine of 150 degrees. And then this one is 3 times the sine of 150 degrees. Since this is 150 degrees, I know it's going to fall in quadrant 2. So when I find my angle measure, my values here, I want to make sure that the ordered pairs look like they fall in quadrant 2. In other words, I want to have a negative x value and a positive y value. Okay, so what is the cosine of 150 degrees? Well, cosine of 150 degrees is negative root 3 over 2. So this is 3 times negative root 3 over 2. And what is my cosine of my sine of 150 degrees? It's positive 1/2. So 3 times positive 1/2, which means that my x value is negative 3 root 3 over 2, and my y value is 3 over 2, or 3/2. So my final answer for this is negative 3 root 3 over 2, comma 3/2. This is my rectangular coordinates for the same point as 3, 150 degrees. All right, so I want you to try the following examples without plotting the points. I'm going to give you polar coordinates and we're going to convert them to rectangular. I'm going to leave this one for you to do on your own, and that's what we'll discuss first thing tomorrow. So I'm starting here with a radius measure of 4 and a theta value of 240 degrees, and let's go ahead and convert that. So that means x equals 4 times the cosine of 240 degrees, and y will equal 4 times the sine of 240 degrees. Now you can either know what values your sine and cosine are for those particular reference areas, or you can go ahead and draw the triangle. Because the last one I actually assumed that we knew that the cosine and the sine were negative root 3 over 2.5. This time I'm going to draw a triangle for you. It's up to you to which way you do it. 240 falls in the third quadrant. And so that means that since it's a 60-degree reference angle down here in the third quadrant, this is a negative root 3, a negative 1, and a positive 2 for my radius. Now remember, this is the radius on the unit circle, which I will have to multiply by 4 because my radius on this polar coordinate is 4. So that puts me down here that I'm going to rewrite this x to equal 4 times, and my cosine is negative 1/2. And then y will equal 4 times my sine is negative root 3 over 2. When I simplify those, I'm going to get negative 2 for my x value, and for my y, I will get negative 2 root 3, because this will simplify here. Now note that my ordered pair in rectangular coordinates is a negative negative, which belongs in the third quadrant. That's a good way to check to see if you've done it correctly. Let's try the next one. So I have negative 2 and 135 degrees. So this puts me at, I know that this theta value is going to place me in the second quadrant. However, because the radius is negative, it's actually going to go through the pole and into quadrant 4. So when we finish, we really want a quadrant 4 ordered pair. But let's start the same way, and it should work out that way if we do this correctly. So I have x to equal negative 2 times the cosine of 135, and y will equal negative 2 times the sine of 135. Now because I'm looking at something located in quadrant 2 at 135 degrees, keep in mind I'm still looking at quadrant 2, that this is a negative cosine and a positive sine value. Now, I know that 135 is another 45-degree reference angle, so I'm really considering root 2 over 2 and root 2 over 2. But I do want to be careful because this is going to be negative 2 times negative 2 root 2 over 2, whereas this one's going to be negative 2 times a positive root 2 over 2. And that comes from the negative here and the positive here. That's how we got the negative on this piece. So this negative 2 in the top, that negative and the 2 in the denominator will actually simplify just to a root 2. And the other one will simplify to negative root 2. So that's your final answer for this one. So you're going to go ahead and take a look at the last one here with the stars on it, 1 comma negative 60, and give that a try. All right, so this time I'm going to be giving you a point in rectangular coordinates, and we're going to turn it into polar coordinates. So we're going to start with knowing that this is x and y, and we're going to convert those. So for the first one, I have r equals, and I'm going to use my square root of 5/2 squared plus 5 root 3 over 2 squared. Now don't be intimidated by this because you're actually just squaring individual parts, and we're all capable of that. So right here I'm going to simplify this to 25/4 plus, and on this side I'm going to square the 5, so I get 25, and then times 3 is 75 over 4. Which means that when I add these together, I'm getting the square root of 100 over 4, or the square root of 25. So this r value is 5. The next thing I'm going to do is I'm going to find out what my tangent is. Tangent of theta will equal the y value over the x value. And we also know that when we have a 2 in the denominator of the numerator and a 2 in the denominator of the denominator, that they will cancel. So this actually looks like 5 root 3 over 5, or root 3 over 1. So where do we have the cosine value to be root 3, the sine value to be root 3, and the cosine value to be 1, or 1/2. And this is the next trick. So if you're not sure, you can always go back and use your triangles. So that would make this root 3 and a 1. So we know that this is a 60-degree angle. Well, looking back at my point, I know I'm in a positive, which means it has to be in the first quadrant. So 60 is the appropriate value. So 5, 60 degrees. Please make sure you use the degrees. It's very important. All right, the last one I'm going to do with you, and then I'm going to leave this 5 root 2, negative 5 root 2 for you to do on your own, is negative 1, positive 1. So for that point, I know my x and y values. So let's start. R equals the square root of negative 1 squared plus 1 squared, or R equals the square root of 2. So tangent equals, or tangent of theta will equal 1 over negative 1. Well, what quadrant is this located in? Quadrant it's located in is the second quadrant. So I just have to come up with what value is tangent equal to a negative 1. Well, it's a 45-degree angle. But that would mean my angle's in the first quadrant, and that's not true. I'm in the second quadrant. So theta actually equals 135 degrees. So my final answer here is the square root of 2, 135 degrees. That's my radius and my angle measure. You're going to take a look at this next one, and then we'll talk about that in class. All right, in summary, this is going to be real quick for you. We need to make sure that we understand the relationship between the x, y, and the r theta that we have. And the best way to do that is to be certain that we can either recreate this or understand where it all came from when we get our formulas together. So my formula to find r when I'm given my x and y is the square root of x squared plus y squared. My theta comes from the tangent of theta equals y over x, so that would be my vertical over my horizontal. And then working back the other direction, my x is actually a relationship of r times the cosine of theta, and y is really a relationship of r times the sine of theta. So if you know these, you're going to be set for basically the entire chapter.